right. Welcome everyone to our session on Amazon EKS, or also known as Amazon Elastic Compute Kubernetes Services Cost Optimization. I'm Dariush, and with me is my colleague Piyush.
Hello, everyone. We're very excited to share some insights on how you all can optimize costs while running Kubernetes workloads on Amazon EKS. My name is Piyush, and I'm joining Dariush. We both are dialing in here today from SoCal.
I'm, as well here in the office today. Zach, so before we dive into cost optimization strategies, let's start with a brief overview of Amazon EKS. Piyush, could you give us a quick overview of Amazon EKS?
Absolutely. If we have a slide, let's point to that. So Amazon Elastic Kubernetes Service, and you see the high-level architecture diagram here, Amazon EKS. It's our managed Kubernetes offering. It makes it easy to run Kubernetes on AWS without needing to install, operate, and maintain your own Kubernetes control plane or nodes.
Absolutely, that's right. So with Amazon EKS, AWS manages the control plane components, and you can focus on deploying and managing your applications. It integrates seamlessly with other Amazon AWS services, giving you a secure and scalable environment for your workloads.
Yes, and as organizations adopt Kubernetes for container orchestration, Amazon EKS offers a reliable and efficient way to run Kubernetes at scale.
Absolutely. But with great power comes great responsibility. So in this case, potential for high cost, if not managed properly, I would say. Kubernetes abstracts away much of the underlying infrastructure, which can sometimes make cost management a challenge. Would you agree?
Yes, of course. And that's where a cost optimization strategy comes into play. Understanding where costs are incurred and how to manage them, it's crucial for running efficient operations.
Exactly. Now, in today's session, we'll explore tools like KubeCost for cost visibility, and we'll discuss scaling solutions like Cluster Autoscaler and Carpenter to optimize resource usage. There was a keynote back in reInvent 2023 by Dr. Werner Vogel, where he emphasized the importance of building cost-aware workloads, particularly relevant for Kubernetes cluster on AWS cloud.
Yes, I remember watching Dariush, and that's what inspired our session as well. When it comes to Kubernetes cost, maybe if you can transition to the next slide, Dariush.
Yep.
Where we showcase the overall cost and the control plane cost. It's fixed at 10 cents an hour. So even when you scale up your Amazon EKS cluster to hundreds and thousands of nodes, there's no additional control plane cost, which is great. The main cost component is on the data plane, which comprises of workload cost, which includes your pods, your containers, your auto scaling parameters, and we'll cover some of that in this session. Next, within the data plane, for some workloads, you incur network cost, which includes pod data transfer, your Elastic Container Registry cost, your load balancers, and costs doing your NAT gateway deployments. And then finally, you incur logging and monitoring cost on the data plane.
Good points. Maybe we should go back to the slide that we had just back here. So when you mentioned the control plane, I see two boxes here. Would you say the control plane is the box on the left-hand side and the data plane is on the one on the right-hand side? So which part is really managed by AWS, Piyush?
I would say the other one, the control plane runs on the AWS cloud, whereas data plane runs in your VPC.
Right.
So over here, what we showcase is a couple of options within data plane. You have self-manage options. There is a manage options, and then there is Fargate as well. So AWS is managing the brain of Kubernetes, right? So to speak, the control plane, the orchestration, and it's on the right hand side. Yep.
Right. And that's where we have the label. If you can see customer V, that's what we mean by the control plane.
Other way around, AWS cloud.
There you go.
Yes.
AWS Cloud. Absolutely. I was looking at the left-hand side. So managed, self-managed node groups and managed node groups on my left by customer VPC, and on the right is AWS Cloud. All right.
Mhm.
So as you can see, this recording is not really scripted. All right. So if you look at the recent CNCF study on the Kubernetes cost back in December of 2023, that's something that we looked at. Yes.
Yeah. If you can move to that study on the deck.
Yeah, perfect.
Yes.
Yeah.
Awesome.
The study confirmed that Kubernetes costs are indeed increasing for many of the organizations that we work with.
Mm-hmm.
Further, the survey revealed that a number of human and technology factors were blamed for the increase in both spend and unwanted and unexpected cost in cloud environments. Now, over-provisioning is by far the most common issue, likely due to difficulties in accurately estimating resource needs in dynamic Kubernetes environments. Failure to deactivate unused resources was cited as another issue, and the presence of the technical debt, not to forget. So the workloads which have not been optimized for cloud-native environments really leads to inefficiencies. Piyush, would you agree?
Yes. No, I think this is a very useful survey from a reputed organization, CNCF.
Mm-hmm.
I have some more surveys. If you can go to the next slide. I think we covered this, reasons for overspend. We covered the over-provisioning and the presence of technical debt. So if you go to the next one where we look at the tooling survey, I would say if you look here, a cloud native default tooling came in first, like AWS Cost Explorer in case of AWS Cloud. In terms of purpose-built tooling for Kubernetes cost, KubeCost came in first. What we see many customers using KubeCost along with AWS Cost Explorer or traditional cloud cost management tooling. So while AWS Cost Explorer will perform overall cloud cost and optimization, KubeCost would be hyper-focused on Kubernetes or Amazon Elastic Container Service, EKS, our managed offering for Kubernetes.
Mm-hmm. Absolutely. Great points here. All right. We talked about the KubeCost, and that's something that probably we can do a quick overview. Is that something that we want to start with, or do we want to go into a demo on a terminal?
Yes, no, let's bring up the dashboard. And now that we've set the stage, if you can discuss more about cost visibility and why do we need it and what's the sense of it. Yep. Mm-hmm.
Awesome. Can you see my screen?
Yes, I do.
Okay, perfect. So what you see here, it's a view of KubeCost that's been deployed, or rather installed, on our EKS cluster. Now, that's a demo version that we're using, but you can also deploy this on your own EKS platform. The reason I'm using the demo, it's got a lot more features than I would have with the free version. Comes into two tiers. One is the free version, one is the enterprise version. Here I'm looking at the Kubernetes cost. Yes, you were going to mention something.
Sure. Yeah, no. So Dariush, what's the challenge here that KubeCost is addressing? Is it getting the cost visibility, understanding where cost is coming from within the Amazon EKS cluster? Is that what it is, or something else?
Absolutely. So it's really within EKS or Kubernetes. It breaks down the cost by namespace, pod, teams. If you have set up labels, for example, for your deployments. It really that breakdown is what some of our customers are looking for.
Yes, and it's particularly important because Kubernetes resources, as some of our viewers will know, they're very dynamic. They can scale rapidly, so it makes it difficult to track costs associated with, let's say, specific applications, specific teams, and that's the space KubeCost is in. That's why KubeCost exists, right? Yeah, go ahead.
And moreover, with the integration of AWS split cost allocation data, KubeCost can provide even more insights into cost attribution in EKS.
Sure. And for those who may be unfamiliar with this new term that Dariush used, AWS split cost allocation data, what it allows for is the distribution of shared costs like data transfer and EBS volumes across various AWS resources, giving a more precise cost allocation.
Exactly. So maybe we should talk a little bit about AWS split cost allocation data.
Sure. Yes. Yeah. Happy to. So I would say AWS has introduced some amazing features to help enhance cost visibility for your Amazon EKS cluster, including the split cost allocation data feature. So this feature, it allows you to break down the cost of shared resource like EC2 instances, networking, and storage into individual Kubernetes workloads.
So what does that really mean for you? Traditionally, if multiple pods are running on a single EC2 instance, you just see the overall cost of that instance in AWS Cost Explorer. But with AWS Cost Allocation, you can now break down the cost of that instance and attribute a portion of it to each workload, if you will, based on their actual resource usage. This makes it easier, a lot easier, I would say, to identify which workloads are contributing most to your overall costs.
Yes, I think that's a good point. And if you were to combine KubeCost's real-time visibility with AWS's split cost allocation, you get a powerful way to track and optimize your cost, right? You'll be able to precisely see where your spend is going, whether it's for CPU, memory, storage, network, and it allows you to take the right actions to optimize your cloud spend. And so together, these tools give you the level of detail you need to make informed decision about your infrastructure and resource management.
Great. Yeah, absolutely. So next, we are going to look at going back to KubeCost and see how it really helps identify underutilized resources. We look at some of the recommendations that we can see on the dashboard. We'll walk through how to spot some of these opportunities for optimization and review the actionable insight KubeCost provides. So let's jump into a quick demo and see how it works. All right. So we can see that we have the overview for the KubeCost dashboard. Under monitor, you have a number of filters, and those filters could be by namespace, nodes, pods, controllers, or containers, or in some cases, environments and deployments. We have here some examples of those, and the more environments you have, or the more departments you have with the labels deployed, you'll get to see it here. One area that I really like is the reports, where you can have a different number of reports created based on what matters to you most. And or last but not least, the most important one to me right now is the savings, where I can see, as you can see, number of options. For example, here, right sizing the cluster nodes. And if you click on it, it comes back. And there's a lot of details where we can get into. But at a high level, we can see that, yes, we are running a series of CPU families, instance families, I should say, and the recommendations which are most important. Going back to insights. Yes.
And I'm just curious, what is KubeCost basing all these recommendations on? So what data does it have access to? Is it some specific data within EKS cluster that it is tapping into and coming up with this recommendation?
Good questions. I don't have the insight of how it really delves into the details of pulling the data. But over time, this is an example of a demo. If we had installed it on our own EKS, could be probably looking at a lot more insight. I would say it looks at the load and the load that is running on the EKS and makes some intelligent decision. In one case, we are running, for example, Carpenter autoscaler, where it decides what is the best family type of EC2 instances or compute that's really suited for your workload. But that's a good question. That's something that maybe we should follow up.
Yes. No, what I see I was just speaking at the documentation. What I see is that there are a couple of different options. One, it queries metrics from EKS, as some of you may know, it's our open source monitoring and time series database. It's installed by default when KubeCost is installed on an Amazon EKS cluster. So KubeCost will query metrics from Prometheus. In addition, it uses API calls to retrieve some public pricing data for AWS services. And then there are some other integrations like AWS cost and usage reports to further enhance the accuracy of pricing information specific to a given account. So it relies on all these information, and then I'm sure there's some intelligence built in, and that's how it's coming up with this recommended savings for you.
Right. And you mentioned Prometheus. I think we also have a managed, I believe we have a managed service of Prometheus and Grafana on AWS where you can also take advantage of.
Counter. Yep.
All right.
Well, this was a great demo. Yeah, this was a great demo.
I wish we had more time to get into a lot more details, but I just want to introduce some of the capabilities that KubeCost gives you. And it's there is a free version that users can deploy on their EKS platform and really give it a spin and see how it works for them.
Yes.
All right. Next topic we want to talk to is about auto-scaling strategies. Let me move that away and go back to our auto-scaling strategies. And we are introducing Carpenter as one option, but no, we talked about the cost optimization, but I think while visibility is crucial, optimizing resource usage is equally important for cost management. Let's discuss scaling solutions in Amazon EKS. Piyush?
Sure. Yeah, I can take that. A lot of folks or a lot of customers we talk to, they're familiar with Cluster Autoscaler. That's how we started. And so Cluster Autoscaler automatically adjusts the number of nodes in your cluster based on the scheduling needs of your pods.
Mm-hmm. Now, that's helpful, but I think it has its own use cases. But in some instances, I see some feedback where it's somewhat slow in scaling times and less flexible with instance type selection, if you will.
Yeah, and we don't make it easy. We have hundreds of instances and we're always launching new instances. So it just amplifies that limitation quite a bit. And that's where Carpenter comes into picture. It's one of our newer open source efficient node provisioning tool. It was built by AWS, and we donated Carpenter to the CNCF as part of Kubernetes Autoscaling Special Interest Group, SIG. So Carpenter aims to improve the efficiency and speed of scaling operations. It's Kubernetes native. And what I mean by that is sometimes your Kubernetes workloads, they may be required to run in certain AZ, certain instance types, pod, on demand. So how do you do that? You need mechanisms like node selector, node affinity, taints and toleration, topology spreads, right? All of these are Kubernetes concepts. So Carpenter works with your pod scheduling constraints, and that's what makes it Kubernetes native.
Exactly. Carpenter can provision new nodes in response to unschedulable pods within seconds, optimizing for cost and performance, really by selecting the right instance types on the fly.
Yes, and it also supports features like consolidation and bin packing, which can significantly reduce cost by making better use of resources.
So let's jump into a quick demo of Carpenter in action and see how it really operates when we try to scale up and down some of the resources. Is that a good time to go into the terminal, perhaps?
Yeah, absolutely. Yeah.
All right.
Maybe if you could start with what's your starting state. I see two windows. If you can provide some more background, what it is.
This is essentially I have an EKS cluster deployed on AWS. And I've logged into I've set the context for the cluster that we're using. The top window, it's an EKS node viewer. It's an open source tool that you can download and install on your Kubernetes or on your EKS cluster. And it really gives you a live view, a near real time, I would say, view into your EKS cluster. On that first line, it shows 3 nodes. In this case, I'm running 3 nodes and 51 pods. On the right-hand side, it gives you an estimated cost of per nodes per hour and or per month, which is to some extent helpful. It's not an exact price, but it gives you an estimate. below that, it also shows you the instance families that are used both by EKS for the main cluster and other resources that you need for your deployment. The screen below, just a terminal screen where you can take a look at get deploy. And you can see here, I have 3 deployments. One is CPU memory hungry app, named after Angry App. And next is Inflate and Nginx. Each one of them, starting from the top, we have 7 replicas, 13 replicas in one. So in this case, we can scale up the replicas on the hungry app from 7 to something else so that we can scale up. So let's say scale up, inflate, or rather memory from 7 replicas to 125 replicas. And before I click...
So before you hit enter, I'm just curious. So up in the top window, we see like 48 pods running. And then at the bottom, we have 3 applications. So it looks like there are more pods. I think that's an interesting one. And part of it is because Carpenter has visibility into the control plane, and Carpenter recognizes Kubernetes resources which are on the Kubernetes control plane. And that's where those additional resources comes into play. Yep.
Exactly, because within EKS or Kubernetes in general, we have a number of different namespaces based on what applications you deploy and the namespaces that you as a user you create. Now, within the Kube system namespace on Kubernetes or on EKS, there are a number of pods that are spun up to support the Kubernetes infrastructure, be it the control plane, the scheduler, the proxies, the core DNS, and so on. So that was a great point you brought up, because looking at the number of pods and looking at the screen below, it doesn't add up. But that's why those are the pods that are not showing, because I'm only looking at a deployment, the number of deployments that I have.
Got it. Yep. So let's scale up your hungry app.
All right. And as you can see on the top, dynamically, it's creating the pods and wait. So pending, running within a few seconds. Or
it's pretty fast. Yeah.
It is pretty fast. It's pretty fast in terms of response. And I really took a big number here, Piyush. Hopefully the demo gods are with us. 25 pending. It's really a simple app, but we can take a look at some of the.
One interesting thing, other one is, so of the 3 nodes, I see 2 are on demand and 1 is spot. It's interesting to me. And perhaps if we can take a look at the configuration, node pool configuration, because there was something in the node pool configuration that made Carpenter decide to spin on demand and spot. And yeah, for the benefit of our viewers, if you can bring it up.
I have a couple of deployments. One is the high priority YAML file, which essentially shows the deployment. The other one is the hungry app. Let's see, hungry app. And
so when you say you mean you have multiple node pools and then there is a way to run them in parallel, assign some weight to it, and then, okay, got it. Yeah, let's take a look at one.
If you want a high priority, just be mindful of time. I'm not sure how much time we have left. But in this case, we have a node pool. We have specified the different families of instances that are available to Carpenter. And one on line 40, the operator, the values are spot and on demand, right? So Carpenter can pick and select depending on the workload that's on Carpenter.
Got it. And what happens is there is this trade-off for spot where if you just choose the lowest price, sometimes you get a very small capacity pool, a pool that's almost unavailable, and it's at a very high risk of interruption.
Right.
So what Carpenter does is it uses EC2 Fleet API feature, which relies on price capacity optimized strategy. So it gives you the cheapest instance type, but then it doesn't give you the one which is about to be interrupted. So there's a bit of balance in there, and Carpenter relies on Fleet API to make that trade-off.
Great point. Yeah, that's a great point to bring up. And we have also a parameter called weight. within Carpenter. Here I have set the weight for 20 for high priority workloads versus a lower number for lower priority workloads. All right, so let me scale down in this case and see. Okay, scale down, going back to, for example, 5 replicas. If the demand on the application that we have deployed, the Hungry app, it doesn't really consume a lot of resources. But if you had an application that would consume a lot more resources, it would spin up additional instance family types like like Spot instance, and if required, on-demand instances. In the interest of time, probably it's a good time to talk about a few takeaways from our discussion. As we have seen, effective cost optimization in EKS involves both visibility and action. Piyush.
Yes, and there are tools like KubeCost that Dariush gave a presentation on that, and it gets you visibility to understand where your spend is going, very granular level, pods, namespaces, and whatnot. Yeah.
Mm-hmm. And scaling solutions like Carpenter allows you to act on that information by optimizing resource allocation in somewhat near real time, if you will.
Yes. And what we recommend at Amazon is don't treat this cost optimization as a one-off thing, something that you do only at the time of migration or when you cut over. Instead, continuously monitor your cost, regularly review your resource optimization or your resource utilization, and then adopt dynamic scaling solutions. We saw Carpenter. Yep.
And also don't forget the importance of right-sizing your workloads and cleaning up unused resources. Small adjustments can lead to significant savings over time.
Yes, and like we discussed, cost optimization, it's an ongoing process. So stay proactive and leverage the tools at your disposal. We showcased KubeCost, Carpenter, but then, there are more out there.
All right. So thank you all for joining us today. We hope you found this session valuable and that you can apply these strategies in your own environments.
Yes, thank you, everyone. And feel free to reach out to us with any questions or any further discussions. And perhaps we can, before we wrap up, let's do a quick recap. If we go to this slide, do we have a slide on that? Yes.
Yep.
Do you want me to take it or? Okay, yeah,
sure.
I can do that. So as a recap, what we did today was we started out looking at the breakdown of your Amazon EKS cost. We positioned KubeCost as a way to get granular cost visibility within your Amazon EKS clusters. And then we highlighted different auto scaling strategies and did a sort of deep dive demo on Carpenter, which is an efficient cluster node autoscaler for Kubernetes. In between, we highlighted how important it is to ensure that these cost optimization strategies are sustainable over a long period, which requires you to establish the cost governance, so to speak. Yeah.
Great points.
That's all we had. Once again, thank you very much for joining and see you next time.
Thank you all.